Hey there, Math Moment Makers. It's Kyle here from MakeMathMoments.com, and I am so excited to bring you another sneak peek classroom edition of a task that actually is going to be a part of a brand new problem-based unit that's going to be up on MakeMathMoments.com. And actually, it might even be there by the time you're watching this at MakeMathMoments.com/tasks. If you head there, you'll see all of our problem-based units of study. And guess what? You get to dive into them right wide open without an account. However, we do go in depth in the teacher guide and manual section. On day one of every unit, you can dive in and explore that teacher's guide and sort of see the visual animations we've done and the walkthroughs, student samples that could be helpful as you try to anticipate what your own students might do. But then on day 2 through however many days are in that unit, you will need to be an Academy member in order to access those teacher guides. However, you are free to use the materials however you choose. So definitely check it out at MakeMathMoments.com. If you're watching this on Facebook, make sure you hit that follow button and the notification button. Or if it's on YouTube, make sure that you go ahead and hit that subscribe button. You don't know how helpful that can be. Leaving comments as well is super helpful so that more educators can see what is out there and available. So we're going to get started here. I want to get you acquainted with the actual problem. This is going to be a problem from day 3 of the unit, and the unit is all about multiplication of fractions. And actually on this particular day, we start to nudge students towards the idea of division with fractions. So dividing a fraction by a fraction. If you're like me, I learned through pretty traditional methods. And when I say traditional, what I'm really referencing is more of like a procedures first approach where, you know, my teacher would show me the steps and the procedures, the rules. They would share some examples, and then I would go and sort of just repeatedly work on problems until I memorized the steps and procedures. And I taught that way for the majority of my career, and it's only been over the last 5 to 8 years where I realized how much I was missing from the picture, the conceptual understanding of mathematics. So I've really made it my professional life's mission to try to better understand the mathematics for myself so that I can help students better understand the math. And now I'm really into, and my mission really is supporting other educators in doing the same thing and really taking you on a journey with myself and John Orr, the other crazy math dude from MakeMathMoments.com. So we're going to get started with this one here. Of course, it's day 3. We certainly wouldn't advise that you dive into this conceptually if students, let's say, don't have a conceptual understanding of adding fractions, right? You'd want to back up to a unit like the snack time unit, which you can find at MakeMathMoments.com/tasks. So again, you want to make sure that students, the readiness conceptually, that they have a conceptual understanding that the strategies and models they've been emerging are going to be suitable for them to address this problem without us pre-teaching all the steps and any sorts of procedures. We want students to develop this understanding and emerge procedural fluency over time. So let's get started. Let's have a look here. I'm just going to switch my camera view here. As per usual, we follow the curiosity path when we start any of these problem-based tasks. And this one starts with a quick little video at my friend's house, and actually is a physics teacher, a good friend and a former colleague from the high school I used to teach at, Bell River District High School. His name is Joel Kaslick, and he is going and flooding the ice here. So as students are noticing and wondering, in the class, you'll see as we shift to the actual class recording, I went in there and basically tried to just give you a glimpse, a snapshot of how things go. Students are noticing and wondering right now. They're sharing things they notice. Some of the things that came up recently were like, hey, this doesn't look like the last house from the last lesson that we engaged in, because this isn't the same house. It is my friend's house. And they notice, like, is that a cooler? They wonder, is that a cooler? They notice, like, it looks like goalie pads down at the far end. All kinds of things. Everything's fair game here to get us started. And I'm just going to give you a heads up before we head into the classroom on where we're hoping to lead this problem. So you'll see how we help nudge students along, how we try to open the conversation for all students to engage here, keeping in mind we want to make sure we know that student readiness is going to be all over the map for every classroom. So we want to give students a way that their voice can be heard, that they feel like there's a way for them, their student voice to be heard, and it's shared in an authentic way. So here, this gives that opportunity for them to get talking and engage. And then we typically narrow down to a prompt or two. And in this case, we're asking, how much of the rink did he actually flood? And by flooding here, we're talking about actually like resurfacing here. And approximately how long did it take? And we get them estimating. So with that, I'm going to cut to the classroom so that you can see what's going on in the classroom, how it might look or sound. Now, note that we don't let you hear the students for privacy reasons or see the students or anything like that, but it is a grade 7 classroom that I'm engaging with. And basically, I'm just recording my screen and you can hear my responses, my prompts as we work our way through the lesson and try to emerge strategies and models that are going to help students make some sense of this problem. You'll notice as they engage here, I haven't given them enough information to actually solve any problem, and that's exactly what we want to begin. So slowly we will give them more information, and we're really concerned that they don't just give me an answer. We really want them to convince me somehow. So if they just say, like, I multiplied this and that, then that's not going to be good enough. We're going to push them to try to convince us. So we sort of pretend like we don't have any sort of math understanding, and it's their job to convince us. So you'll see that process. So enjoy it, and we will see you on the other side of the video. If you're watching on Facebook or YouTube, do us a huge favor. Again, hit that like button, share it with some colleagues, share it in your favorite group. If you're on YouTube, again, comments are huge. Hit that subscribe button and the bell. It'll really help us grow the channel so that we can help more educators and in turn, more students in the end. So we'll see you on the other side here. Enjoy this glimpse into a grade 7 virtual classroom. I'm wondering here, is there a heater? No, I'm going to confirm that, but the water is heated. And shaving the top layer, I'm going to say like, comme ci, comme ça on that one, because he does have some towels dragging, and someone had mentioned that that the ZAM cooler was spilling water, and that is correct. He is letting the water out the back, and there's like a towel that's sort of taking the top layer off by heating it up, but it's not like scraping it off like a Zamboni would. So yeah, go ahead. What are you thinking? Super, super cool. I love that. I love that notice for sure. So we've got like lots of great noticing, lots of great wonders here. But I'm going to give one of my own wonders here, if that's okay with everybody. What I want you to do is I want you to take a moment and I want you to pause and look at this ice rink and check out how much of that ice rink Mr. Kaslik has actually resurfaced. And the question I have for you is, how much of the skating rink do you think he flooded here? And of course, this is an estimate. And about how long do you think it took him? Now, I want you to pause before you hit the enter button. We're going to pause. I want you to think on this first. First of all, I want you to think about about how much of the rink has he flooded so far. I'm going to play the video again so you can see it. But then secondly, what I want you to do is think about about how long do you think it took? I do want to warn you though that the video, which I'm replaying right now, is actually sped up. Okay, so you can't just count it out or time it with a watch here. You're gonna have to, kind of use a little bit of your own approximation skills here to figure this thing out. Yeah. By flooding, sorry, that's like a term. We should actually cover this in the notice and wonder part. When they resurface the ice, oftentimes a lot of people say it's flooding the ice because you're actually putting some. If you see over here, you're actually putting some water on the ice, so they call it flooding. It's kind of like a slang term when resurfacing the ice. All right, so this is the thing we're going to have you estimate. I want you to think about this. 2 things you're going to be getting ready in the chat. And then also, if you're interested in sharing, raise your digital hand and we will give you an opportunity to do that and share it verbally. So I'm going to give you about another 15 seconds or so. I love it. I love it. It's so unfortunate that Teams doesn't give you 2 digital hands, right? Like, I feel like that is just such a shame, but that's all right. Okay, let's see. On the count of 3, we're going to hit enter. All together, I'm going to have Miss count down from 1 to 3. And on the count of 3, you're going to press enter to share. And then we'll have anyone share verbally as well. All right, Miss? Yeah, I'm thinking if you can jot down like how much of the ice, I'll put it over here. And then about how long I'll put next to it as well. What do you think? 2/10 of the ice and about 15 minutes. Awesome. Super cool. Oh, so like a lot less time for that one there. Okay. Now I'm wondering, Miss, is it too much trouble? Like, who said the 2/10 and 10 minutes? I'm going to try to put a couple names to these here if we can. With an H? No H. Perfect. Okay. And agree with Josh, maybe like 15 minutes, I'm guessing. And sorry, I didn't catch the name here for 2/6. And this one was Katrina with a K? Super cool. We've got lots of estimates here, which is great. I love it. I love it. Holy smokes. So like, I'm just, for my own sake, I just want to like take this and try to visualize this for myself. Like, I'm going to look at this for a second. 2/10. So if 2/10 is what we have, it's like I'm visualizing me partitioning this into 10 pieces and 2 pieces are full. I feel like that feels pretty good to me. When I look at 1/5, okay, 5 pieces here. It's like I would have like 1, 2, 3, 4, and then this would be the 5th piece. Like, that feels good to me as well. 1/6 would be really close to that as well. Another 2/10, and then a 2/6 as well. So if I had 6 pieces, 2 of them full. Holy smokes, I feel really good about these estimates. The times, I'm going to admit, it's really hard to estimate right now. Would you all agree? Like, it was sped up, so it's really hard to know like how fast was I sharing that video. So we're not going to like sweat too much on that yet. But Miss, I want to keep going here a little bit, and I'm going to reveal first how long it took, and I'm also going to reveal about how much is covered here so we can do a quick little celebration. Again, here's what we had, some of the estimates. Some others are in the chat, which is amazing. Hold yourselves accountable. But let's watch a quick little clip here and let's see what actually happened. Most importantly, I want to see like how much of this was covered and how long did it actually take. Here we go. All right, let's get this under control. Look at that. And 1 minute and 15 seconds. 1:15. I'm looking, who was closest here? 1 minute and 15 seconds for time. What do you think? Was anyone closer than Mila in the chat? Sarah said about 1 minute. Oh, actually, yeah. What am I doing here? This is closer than 3 minutes, eh? So Nick said about 1 minute in the chat. Super cool. On the count of 3, we're going to do a out of sync clap all together. 1 clap together. If you want to turn your mics on, it's going to sound like a beautiful harmony of claps all over the place. On the count of 3, 1, 2, 3, 1 clap. Awesome stuff. Listen to that beautiful, like, it sounds like an orchestra of clapter. Clapter? Is that a word? I have no idea, but that's okay. We're going to keep going though. I totally do. Totally make up words. I'm also going to reveal that we actually had a few people who guessed and I don't even want to say guess, because this was a really good estimate. You had a visual of the ice, and I can confirm that this chunk, that is 1/6 of the ice. So awesome stuff there. I see Katrina, I saw Sarah, like Grace was off by a 1/6. 1/5 was really close as well, Mila. So anyone who said 1/6, awesome stuff there. Oh, I love it. That is fantastic. Here's what I want to keep going. I want to keep rolling this along because, as you can imagine, Mr. Kaslik did not stop with covering the ice here. He actually took a break and he had to refill the cooler, okay? He had to refill the cooler with his hot water, his hot, we'll call it ice magma, okay? If you're doing any volcano exploration. And he went into the house. He had 1/6 of the ice done. And I'm hoping, and I know you're all fraction ninjas here based on what I saw last time. So I'm guessing most of you realize that there is like 5/6 of the ice left. Now, when he came back out, all right, I think he went a little bit further, or at least a little bit faster, because I feel like he covered a little bit more ground in session 2. Now, I don't understand this. I can't figure it out. I'm hoping to ask him sometime soon. But when he came back out and he started his second flooding session, what he actually did was he started going like here, he was going like vertically, and then he came down and he actually started going horizontally, and he flooded about that much of the ice. So now I want you to think about how much of the skating rink do you think he flooded during session 2? Now, I want to be really clear on my language here. What I'm asking you to do is not to figure out what fraction of the remaining ice did he do. I want you to try to approximate, like, how much would this represent compared to the entire ice rink? So when he went and he actually went and did session number 2, how much of the entire ice rink did he end up completing? And then I'm going to give you a little more information to update your approximation, okay? So I want you to think about this first. If you're feeling pretty good about that, I'm also going to ask you to approximate about how long do you think it took him, given the fact that it took him 1 minute and 15 seconds to do the 1/6 slice. About how long did it take him to do this one here, given all of that area that he covered? So I'm going to pause here. Miss, is there anything we need to clarify there? Was there anything that was unclear? Or do you think they are ready to rock? Yes, absolutely. Hold our horses. We want to do this. And also, I really want to encourage you, my friends. I want you to draw and like be able to prove this to me. Now, Miss, I don't know if you want to do this in, I don't know what you decided, if like in OneNote you want them to share or if it's in a Padlet. I'm going to let you decide on that. But I do want everyone to have a model so that they can reference and sort of like convince us based on their estimate. Now, remember, it's an estimate, so everyone might have something a little bit different, but we should all be convinced based on your estimate. Is that okay? Is that clear? And I'm just going to kind of model like my crazy ideas on how I try to like partition. Because if I just go at it like straight up, I'm going to be in a world of hurt because it's not going to be very accurate. So like I see there's half. Oh, there's 1, 2, oh geez, there's fourths. Like this is going to be tough for me to do with markers. I'm going to need something smaller. Yeah, let's see. I don't know. But I'm going to do this just so that everybody has an opportunity here to approximate. Oh yeah, you're so right. I'm such a silly guy here, eh? I'm so out of practice. There we are. Awesome. Oh, I love it. No, that's okay. I'm just kind of, you know, I hope everyone saw like this is just one strategy to help with partitioning. So I'm going to let them do whatever they choose. I'm really curious to see how they partition this. I've only got 1/6 so far. So like there's like where I'm at. So if you folks are way ahead of me, then like good on you. Alrighty, hang tight though, okay? Hang tight. Make sure that your visual will be really helpful for everyone to kind of get a sense of where of what your thinking is, okay? Now, I don't know if you can tell, but I'm like on the screen, I'm taking my marker and I'm trying to like figure out, where is that? Where am I gonna put that chop? And I feel like for me, it's like right around here. All right, mine's not perfect, okay, my friends, but like that's my kind of approximation. I may have even wanted to go a little higher personally, but maybe you think it's great where it's at. I don't know. I'm gonna do that. And like this is where session 2 happened here. So Mr. Casa came out and he did all of this. Now something I'm noticing is like my partitions for sixths kind of gives me like a little bit of a, something to work with there. Now I'm just wondering like where else I would partition. I'm not sure, like would I do it, would that work? Would this work? I'm not sure, I gotta kind of play with that a little bit. All right, I'm gonna pause there and I'm gonna put this back on the screen. I'm seeing one on a screen right now. I'm gonna snag that and see if I can pull that up. That was Sarah, I think. Sarah, checking this out. Super cool. Like Sarah, are you able to turn your mic on and kind of like walk us through this a little bit? Like what are you thinking here? Like I see your 1/6 here, so I'm kind of visualizing, forgive me if I don't mean to like draw all over. Oh no, I didn't want to do that. Holy smokes, what are you doing, Mr. Pierce? Here we go. I want to grab this and I'm gonna like, so this is like your 1/6 here, this little spot right there. Super cool. Can you tell me more about this area? Like what's happening here? What's your thinking? Oh, super cool. Into fifths. So I'm seeing, so correct me if I'm wrong, like this is a 1, 2, 3, 4, 5. Awesome. And about how many fifths did you think was cleared during this second time around? 3. So you went like this and you were like, okay, I'm gonna go ahead and there's like 1/5. There's like 2/5. I know it's not perfect because you know yours was on an angle or whatever, but we kind of see this here, and I bet you probably be better if I made this blue to match. I don't know. Let's see, like there it is. Holy smokes. I'm wondering, anybody else out there feel good about that? Like Sarah's saying 3/5 of the remaining ice. Oh, holy smokes. I see 6/10. Cameron, I'm wondering, Cameron, yours is 6/10. Is yours like way off or is yours like close or what do you think? I'm even gonna snag it here and try to bring it up side by side. What do you think there, Cameron? Yeah, like is 6/10 like close to 3/5? Is it a lot bigger? Is it a lot smaller? Like what do you think? I love it. But I'm wondering though, like, and I don't mean to put you on the spot, but like, is your estimate like bigger or smaller than the 3/10 estimate? Interesting. I'm wondering, anybody else like have any thoughts on that? Like, what do you think? 2/5 remaining. So like so you're saying that yours like is 6/10 like more or less than 3/5? And anybody else want to help us? Oh, it's the exact same. Holy smokes. I don't know if you folks like see that, but like if I was to take these fifths and make them into tenths, like check this out. I would be halving my fifths. Like, look at this. Like if I half this fifth, I get 2/10 here, right? I get, oh, it's not copying and pasting very well for me, but you can kind of see it's like I get 2 for every one here. 2, 4, 6, 8, 10. And there would be 6/10. Holy smokes, I'm loving that. There's so much awesomeness here. You know what's one thing though, Miss, I haven't heard from the group yet? And it's really, like, I don't want to say it's bugging me, but it's like it's on my mind for sure. What I am wondering about is everybody told us approximately how long it would take, or no, sorry, how much of the skating rink compared to what was left. But what I really want to know is like, what would this fraction, and I'm even going to tell you right now, I'm going to confirm for you that it was 3/5. Like, you folks were amazing. But my real question was, how much of the entire ice rink does that blue area represent? So let's give them that time. And I'm really curious, especially, was it Cameron who was telling me about the 4/10? Josh. So Josh, in particular, I really want you to help me see your 4/10, okay? And if you decide it's something different, that's cool too. But I really want you to make it visual for us, because I think I saw what you were saying, but I don't know if everybody got that same understanding. So for everyone else, same thing. Maybe you came up with a different number. I don't know, but we're really interested to see, how much of the entire ice rink is covered. And Miss has it all set up for you. Yeah, make sure you show it in that OneNote, okay? Yeah, like I'm just jotting this down for myself, and I'm noticing it's like you've multiplied the numerators, multiplied the denominators, and then got an answer. I'm just wondering, like, what's actually happening when we do that? Like, what's happening there? Like that, I would be so interested to figure that out. Cool. Yeah, let's have a quick peek here. So basically what I'm hearing a lot of friends are sharing something very similar, but the part I'm struggling, Miss, I don't know about you, if you're struggling with it as well. I'm just going to draw this in. Again, notice my little strategy here. I'm using little sticky notes I've cut up to try to help me with my partitions. I find if my partitions are way off, like I didn't do it with the 6th, and look at this. Like, this is way bigger. It really throws off my my visual. So I'm trying my best here, and I'm just going to go ahead and show, like, we knew that 3/5 of the remaining 3/5, this blue area represented 3/5 of the remaining 5/6. So you can see I've written that symbolically. So in session number 2, we did 3/5 of the remaining 5/6 of the rink. 1, 2, 3, 4, 5. This 1/6 was already done in session 1, so that's kind of taken care of. But the part that I'm struggling with is that I'm seeing a lot of people multiplying like across, and I guess my wonder is, like, how do you know that's going to work? And when I'm looking, and I know we only have a couple minutes, so I can't put it out to the floor right now because I want to make sure we wrap this thing up. What I want you to see, though, is this idea that basically when we have 3/5 of the remaining 5/6, when I get this in, and this is what happened in my group, and I think it was Josh who was saying, you know, it was like it was almost like I ended up having the drawing because they said, well, it's 3/5 of the remaining chunk has been done. So we sort of drew this out, what this would look like. And then the answer becomes pretty obvious to us when we check it out and say, well, wait a second, if this is all session 2 right here, I can see that chunk. I'm just going to make the chunk a little bit darker here for us. It's there. So we can see that chunk. And what I'm hoping that you can notice here is this idea that 3/5, this is 3/5 of a different whole, like of the remaining chunk. And the remaining chunk was 5/6 of the entire ice rink. And when I look at that and I go, well, wait a second, where are why did so many people multiply 3 times 5 to get 15? Well, when I look at this, I go, wait a second, the part I'm interested in is actually 3 rows of 5 columns, a 3 by 5 array. So this right here is a 3 by 5 array, and that represents my chunks. So I have 15 chunks here, but now the total number of chunks relative to the entire ice rink has changed. Before, we had the total ice rink chunked into 6ths, which you can see here. And now what we've done is we've said, no, now we want the chunks to be these little ones here. And when I look at it, now I have an array of 5 by 6, and that partitions the entire whole into 30 chunks. And then from here, I heard some people say like, I'm reducing the fraction, but I'm gonna use a slightly different language with you, because actually, when you go from here to lowest terms or simplify, we are not reducing anything. It is equivalent. Right here, this is equal to this is equal to this. The fraction itself is not getting smaller. The quantity is not getting smaller. It's just that we're simplifying the numbers we're going to use to represent the same fraction. So you'll notice 15/30ths is right here. Here's 15. There's 30. And then all I need to do is kind of just mix and match and go, well, wait a second. What if I want to make this into smaller chunks? I could try to make groups of chunks. And actually, I already did this in kind of a nice visual way. So if I look at these chunks here, totally. Yeah, absolutely. So you can kind of, yeah, you can definitely see that here. Like there's the 15/30ths we just saw. Now, check this out. If we take that, we can actually move this around and see 1/2. Like, do you see 1/2? I'm gonna take that 1/6 from session 1 and fade it out. But if I take the blue chunks and I just move it a little bit, can you see how that is the same as 1/2 of the entire ice surface? So it's like your chunks change a little bit. It's almost like you can ignore all these partitions now and look at it as one big chunk out of two big chunks. And that is called simplifying the fraction. It's actually not reducing the fraction itself. Super cool mess. I'm wondering, before they set off on their little break time here, I wonder if one of the things we have them do on their own is figuring out, so how long is that going to take? And we'll have them do that like later. You can decide when, but how long is it going to take if that represented half of the ice and we knew 1/6 of the ice took 1 minute and 15 seconds? Thank you, everybody. I had a blast. I'm really curious, Miss. Let me know how they do on how long that'll take. And I hope I get to come hang out with you all again soon. All right, Math Moment Makers, I hope you enjoyed it. I mean, I'm going to assume that at least you were engaged because you're still with us, and it's been a number of minutes. So I'm really, really happy that you engaged in it. I do want to, before we head out, I do want to just let you in on a little secret, and maybe it's not a secret for you, but for some people it might be, because we left students to ponder with how long it should take to complete the section number 2, which is that blue area. We already shared with students that, like, you know, you could see 15/30ths is the same as 1/2 by just kind of like fading out that, that little orange spot. But something that students might not realize, and maybe even some educators might not realize, maybe you don't realize, is that this question about how long it should take to complete the section, what I'm anticipating is that students are going to be able to come up with an answer that's either precisely 3 minutes and 45 seconds, or somewhere in that neighborhood, just even if they were just estimating, just by kind of looking and reasoning through this problem. Now, what I'm going to anticipate a lot of students are going to do is they're going to say, well, that orange strip is 1/6, and I can see that there's like 3 of those strips over there, like 3/6, which is also equivalent to 1/2. So like you can see there's like one of them. So that's 1 minute and 15 seconds. There's like a second one. So there you go, 2 minutes and 30 seconds. And then finally there's a third, and that's 3 minutes and 45 seconds. Now, the part that students will not likely know or notice, and this is where we need to be able to notice and name as the educator, and maybe you at home might be watching this. If I ask you right now, like, what operation are we using to make this happen? And you might even want to pause the video to think about that. Like, what operation are we actually using? And like, what is it that we're doing? And I don't want to, lead you too much here, so I'm keeping it pretty broad. But like, think about that for a second. Like, what are we actually doing? Now, if you said we are multiplying, like I'm taking that 1 minute and 15 seconds and I'm multiplying it by 3, I'm going to say you're right. That is true. Some people might say I'm taking 1 minute and 15 seconds and I'm adding it 3 times, right? It's same as multiplication, right? So 3 groups of 1 minute and 15 seconds. Totally cool. Here's my next prompt though. I'm going to ask you, and this is the same thing I would ask students when we go back in here to consolidate what they went away with and they're going to return to class with the next day. What I'm going to ask you to think about right now, and maybe pause this video, is where did the 3 come from? Okay, so what I want to know is like, what operation are you using and what numbers are you operating on? What values, quantities are you operating on in order to get the 3 groups? Like, we know it's 3 groups, but I'm wondering, how did you know and how can you like prove it mathematically? Now, if you're like me, for many years, I probably would have had a hard time articulating that. I would have been able to give you an answer. I would have been able to tell you, you know, like it's 3 groups of 1 minute and 15 seconds. But I just want to reveal to you that like what's hidden in this problem is actually a division of fractions problem. Like what we're actually asking students to do is we're saying, okay, listen, we have half the ice is section number 2. And I want to know how many 1/6 are in half of the ice. So like think about that for a second. This is a division problem where I want to know how many 1/6 are in or are comprising this 1/2. Now, something else that you may not be aware of, I don't care what grade you're teaching. I don't care, you know, if you have a math degree or not or whatever. I have a math degree. I went to school for mathematics and I taught math for over 15 years. And I did not know that there's actually 2 types of division. So this is one of the 2 types of division. This is a quotative division problem because I'm looking to figure out how many times can 1/6 go into 1/2. All right. Now the other type is called partitive, where you're actually trying to split a quantity into a certain number of parts. Now, right now you might be like, maybe your head just exploded, okay? Because like that is a really, really hard concept to understand. So if you're thinking and you're like, I'm not sure about that, that means that you probably want to back up to working with division. And I would encourage you to go check out one of our earlier problem-based lessons or earlier problem-based units, one of which is the Whirlpool Aero Car unit. It's all about an attraction at Niagara Falls, Ontario, and in there we explore the 2 types of division, and you do this with whole numbers. Like if you're not sure of the 2 types of division and you aren't flexible with them, I can't expect that you're going to be flexible with division and fractions. So if students are struggling with fractions or they're struggling with operating on fractions like multiplying or dividing, I'm going to guess that maybe they're not using a model. They're not seeing this area model we're using up on the screen, and they're not understanding the strategies on how to go about that. That means we're going to probably have to back up a little bit and build our fluency and our flexibility with those models to understand conceptually what's happening and then work our way along. So there's a lot going on here. Like for many of you, you might look at 1/2 divided by 1/6, and what you would do naturally is like, I'm going to take 1/2, I'm going to multiply by 6/1. Right? Because that's like what I was told to do in school. I'm going to like multiply by the reciprocal. And that works, but then the question now becomes is like, why does it work? Right? So exploring through math models is something that we really want to do so students can build their conceptual understanding, because guess what? Memorizing steps and procedures, it might work for short term, but in the long run, they're going to forget these steps and procedures. So they have to go back and relearn the steps and procedures. But again, for what purpose? They can't reason with steps and procedures. They have to actually have a conceptual underpinning in order to reason and prove in mathematics. So I just wanted to share that with you, noting how I would approach this. Like, so if I am exploring and your students are ready to explore division of fractions right now, like this group, I was going to nudge them here. I would be curious to see how they would do this and like how, you know, like what do I need to do to figure out how many 1/6 are in 1/2? Well, I can kind of see it. I go, well, 1/2 is the same as 3/6. So I can see that actually, like, I can almost think of this as like 3/6 divided by 1/6. Just like you would take 3 meters and divide it by 1 meter, and you would say that it's 3 groups, right? You can tell there's 3 of them in there. The scale factor would be 3. Well, here we can think of the unit fraction, sixths, as a unit, just like centimeters or meters or inches or whatever you're doing, counting candies. It doesn't matter what it is. 3 divided by 1 is 3, and game over. We're done. There's no flipping, turning it to multiplication for who knows why. Like none of that has to happen. We do have to have an understanding of equivalence, though. But I know that 1/2 is the same as 3/6, and there are 3 1/6 groups in 3/6. So we're good to go on that front. We can see that. Like, it's so easy to see here with this model to help us see. It's like, boom, it's going to take 3 of them. And that means I'm going to have to multiply the first section by 3, or the time it took for the first section by 3. So I just wanted to share that with you, my friends, and give you a little bit of something to take away with. On this day, we also give a consolidation prompt. Like, that wasn't supposed to be the consolidation prompt, but students were like really grappling through this problem. That's a good thing. We want them to productively struggle through this problem. But this was what we had intended to ask them, is like, listen, what fraction still needs to be flooded? Students in my group, or in this class, actually already were telling me that number through the chat. And then we asked them to write an equation to represent the fraction of the skating rink that needs to be flooded, of the whole rink. And how long do you think it'll take? And finally, justify. So this would be like their ticket out the door. Like, figure out that green little section, like how much of the whole is that? What does it look like? Can you create an equation? Or I would accept an expression if they're not creating an equation, but we'd want to make sure they understand the difference, and then we'd have them work through that problem. So that, my friends, is day 3 of a unit that will be coming out. It's called Shoveling the Driveway. Day 1 starts with shoveling my driveway, and we do something very similar here. And now we're kind of nudging and kind of working our way towards division and building fluency and flexibility with fractions. And keep in mind, my friends, that you can go and grab like all of these tasks. Like, there's so many of these different tasks for you to check out on our website at makemathmoments.com/tasks. And they are all there for you to check out. So make sure you go and do that. Also, if you want to learn how to become more fluent and flexible with running problem-based lessons that follow our curiosity path and our 3-part framework, then you might want to go and actually check out our guide. It's a 3-part framework guidebook. And this is our Make Math Moments 3-part framework. It is really outlines exactly what we're thinking about as we're planning a problem-based lesson and really a problem-based unit. So make sure you go check that out. Again, do us a huge solid. Hit that subscribe button and the notification bell wherever you are, Facebook, on YouTube, whatever it might be. And again, grab that guidebook if you want kind of like basically a little bit of hand-holding through how you can run problem-based lessons. That is it for me. My name's Kyle Pierce, again, from makemathmoments.com. And hey, I haven't mentioned it on any of these videos yet, but we also have a podcast. So go check it out on your favorite podcasting platform. Ask Alexa, ask Siri to turn it on, whatever you're listening on. It'll find it for you. Making Math Moments That Matter is the name of the show. And listen, we are so thankful that you watched to the end. And I can't wait to do some learning with you again real soon. So take care.